Hello everyone, I am Sreeja from 4th ECE. Today I am going to explain about block transform coding. First we should know what is transform coding. Transform coding compresses image data by representing the original signal with a small number of transform coefficients. For most images, a significant number of the coefficients have small magnitudes and can be coarsely quantized with little image distortion. So we have a variety of transformations to transform the image data. Some of them are DFT, DCT, WHT and KLT and so on. We have number of varieties of transformation. Here is the block diagram of the transform coding. First, we will give the input image of size m into n. Then, we will construct a sub-images of size small n into n. Then, these sub-images were forwarded to a forward transform for the transformations, and then the transformed images got quantized and finally symbol encoder and sent to the symbol encoder. From there we get the output, which is compressed image. For decompression, we do first the compressed image should be sent to the symbol decoder, and then we need to apply invert transformation, and then we need to merge all sub n into n images so that we get the decompressed image, which is the input image, starting input image we will get. So this is the explanation about the block diagram. So first an m into n image is subdivided, then and all we have the criteria here about this block diagram. Transform selection. Since we have a variety of transformations for transform data, image data, so we need to choose the best accurate transformation to transform the data. So the choice of a particular transform in a given application depends on the amount of reconstruction error that can be tolerated and the computational resources available. So compression is achieved during the quantization of the transformed coefficients, but not during the transformation step. With the reference of this discussion, now let us consider a subimage g of x comma y of size n into n, whose forward discrete transform T of u can be expressed in terms of general relation. So T of u T of u comma v is equal to sigma y equal to 0 to n minus 1, sigma x equal to 0 to n minus 1, g of x comma y, r of x comma y comma u comma v. Here u comma v are from 0 to n minus 1. For this given t of u comma v and g of x comma y similarly can be obtained using the generalized inverse discrete transform. Like as t of u comma v, we can generate for g of x comma y also. So g of x comma y will be equal to sigma u equal to 0 to n minus 1, sigma v equal to 0 to n minus 1 t of u comma v s of x comma y comma u comma v. Here also for u comma v is 0 to n minus 1. In this equations, r of x comma y comma u comma v and s of x comma y comma u comma v, these are called the forward. These are called the forward and inverse transform kernels. Okay, respectively. Means r of x comma y comma u comma v is called the forward transform kernel, and whereas s of x comma y comma u comma v is called as inverse transformation kernels. So these are also referred to as basic functions. These are also referred as a basic functions or basic images. So the t of u comma v, for which u comma v equal to 0 to n minus 1, this is called the transform coefficient. They can be viewed as the expansion coefficient. They can be viewed as the expansion coefficient. So from this transform selection, we will choose one transformation. That is one of the transformation used most frequently for image compression is discrete cosine transform, that is DCT. We'll use DCT for this. Let's see about DCT, discrete cosine transform. DCT is very popular due to its computational property. Okay, the discrete cosine functions consist of a set of basic vectors that are samples cosine function. So DCT is a technique for converting a signal into elementary frequency components and is widely used as image compression. This DCT is used for the image compression. Okay, to perform the JPG coding, an image is first subdivided into 8 into 8 pixels. Okay, now the discrete cosine transform is then performed on each block. So since we have divided the blocks, sub blocks, so this DCT will be performed on the each and every block. This generates 64 coefficients which are then quantized to reduce their magnitude. Next, the coefficients are then reordered into one-dimensional array in a zigzag manner before further entropy encoding. So, during this compression, there are two stages which were achieved. That is, the compression is achieved in two stages. Okay, first is during quantization, and second is during the entropy and coding process. Okay, yeah. So the DCT based courses uses a two-dimensional version of the transform. The 2D DCT and its inverse IDCT of a n into n block are shown below. First, 2D DCT. We'll see the formula for the 2D DCT. That is f of u comma v is equal to 2 by n C of u, C of v, sigma y equal to 0 to n minus 1, sigma x equal to 0 to n minus 1, f of x comma y cos of 2x plus 1 into 4 pi by 2n into cos of 2y plus 1 into 4 pi by 2n. So this is the formula for the two-dimensional DCT. Now two-dimensional IDCT, inverse discrete cosine transform. Okay, that is small f of x comma y is equal to 2 by n, sigma v equal to 0 to n minus 1, sigma u equal to 0 to n minus 1, c of u, c of v, f of u comma v, cos of 2x plus 1 into 4 pi by 2n into cos of 2y plus 1 into 4 pi by 2n. So here f of x comma y, small f of x comma y is n into n subimage, hence it is a matrix F, small f. Next, similarly, capital F is transformed matrix and CB cosine matrix. We can obtain capital F by following formula, that is F equal to cosine matrix into capital small f into cosine matrix transform. Okay, cosine matrix transpose F equal to C transpose. So cosine matrix can be formed with the help of the following formula, that is C of u comma v, which is cosine matrix, that is equal to root over 1 by n if u is equal to 0, otherwise root over 2 by n cos of 2v plus 1 into pi u by 2n. Okay, this is the formula, this is the condition for cosine matrix. Okay, likewise we can construct for 4 cross 4 into 4 cosine matrix by substituting the indexes. Okay, this is the 4 into 4 cosine matrix. Okay, likewise similarly we can obtain for 8 into 8 and 16 into 16 cosine matrix. This is the 8 into 8 cosine matrix, 8 into 8 cosine matrix. Next, similarly, this is the 16 into 16 cosine matrix. Hence we use above C matrix in capital F, that is F equal to C into F into C transpose, and hence and obtained the transform coefficients, which is further quantized, so it gets more compressed. Okay. So this is all about transform coding. I hope you all got understood about the topic, and this is the reference I took for this preparing this video. Thank you.